Experiment 12, determination of the value of the universal gas constant R. And the way we're going to do it is by measuring the pressure, volume, temperature of a certain number of moles of gas produced by the reaction of magnesium with hydrochloric acid. So we have the apparatus all set up. So to demonstrate this, first, personal protective gear. We weighed out 0.0407 grams of magnesium. I'm going to roll this into a little ball. As magnesium doesn't react with copper, we're going to wrap it up, in just some copper wire.
You mean hydrochloric acid doesn't react with copper?
That should be, we have plenty of copper wire. Hopefully we don't have it wrapped up so tightly we can't get at it. Then what we're going to do is we're going to take, this is called a eudiometer, we're going to put some hydrochloric acid in there, and then we're going to set up the reaction. So concentrated hydrochloric acid is nasty, so we're going to work with it in a fume hood. You don't need very much of it. Basically just one squirt. More than sufficient. At the bottom here.
It's supposed to be 6.
Maybe 2 squirts just for a little extra love. And the idea is that we're going to measure the volume of a bubble of hydrogen gas. So it's important to ensure that we don't have an air bubble because air and hydrogen look exactly the same. So what we're going to do is we're going to add deionized water. You can see the hydrochloric acid down here. Because deionized water is less dense than concentrated hydrochloric acid, we add it slowly at first. We can float the water on it because we don't want this reaction to happen until we're ready for it to happen. And if you look carefully, you can kind of see it mixing. And as we get more and more, we can tip the eudiometer. And this is a good way to deal with your aggressions, just squeezing the deionized water. Talk amongst yourselves. By the time we get to the top, this is almost pure deionized water.
I'm going to pause.
So we are literally now all the way filled. So now I'm going to take the magnesium wrapped up in copper, put it in here, and see some water come through so there's no air. I'm going to put my finger over the holes, flip it over, put it in a container full of just regular water. And this method is called downward displacement of water. And so you can see as the hydrochloric acid works its way down, I don't know if it'll show up on the video, but it's working its way down, and eventually we'll start seeing some bubbles rise up. Those bubbles are hydrogen gas. Give it a moment. It's got to react with a little bit of oxide coating on the magnesium first. You can see a couple of small bubbles coming up. So those bubbles coming up are hydrogen gas, and this will get going pretty good. And there's holes in the stopper, so as the hydrogen gas bubble gets larger and larger, it'll push water out, and then we simply measure the volume of that gas. Look at it go. Also measuring the temperature. And we'll just say that the temperature is 24.
Action.
All right, so you can see that the reaction is complete now. And so what we have, the air bubble is just a little bit below the level of the meniscus in the cylinder. And so that means that the pressure in the eudiometer is a little bit higher than the pressure in the room. So what we want to do is raise it so that the menisci, which is plural for meniscus, are at the same height. If you pull it up a little, though, you can actually see, if you look at, as I go up and down, you can see the meniscus moving. That's a good example of Boyle's law. So what we're going to do is we're going to get it to this height right there, and I'm going to do my best to read it. And so it looks like it says 38.2 milliliters. In addition, we measured the temperature and the pressure, and the temperature of the air, the temperature of the gas is 24.0 degrees Celsius, and the pressure is in the room is 31.01 inches of mercury. With all this data, we can calculate the value of R. That is for you guys to do.